Welcome everyone to the expert-led workshop on NSX Cloud, consistent networking and security across enterprise, AWS, and Azure. Our session's agenda today is we will go over the introduction of hosts of this session. Then we will jump into how we constructed the lab experience, and instructor guided lab. In instructor guided lab, I have few slides about NSX Cloud and their components, the solution and the components that I'd like to go over. And after that, we will jump into the lab exercise itself. We will pick one of the modules of this lab and we'll do the module live. And that time you have two options. You can sit back and relax and watch us do the module and really learn about the product and the features, or you can do the lab with us. So we'll try to go slow with our pace. You'll be able to do the lab. Great. Let's start with introductions. My name is Puneet Chawla. I'm a senior technologist here at VMware. And my co-host, my co-presenter, the co-captain of the lab, who we build this lab together, is Muhammad Haddad, and he is VCN Senior Engineer here at VMware. Let's jump into construction of the lab. We constructed the lab in three parts, three phases. First one was constructing the vPod itself. This is where we built our management plane and also compute plane. The resources for this vPod live on premises in our data center. And what we have done once we made all the management plane and component plane and configured everything, deployed all our SDDC components, we captured that vPod and we deployed multiple times. So each individual labs get their own vPod. Second, we also built our compute plane in public cloud, in AWS and also in Azure. Both of these are identical, and the way we automated the process is through Python Boto 3 APIs for AWS side of the cloud and in PowerShell for Azure side of the cloud. And these scripts not only provision the lab or the resources that we need for the lab in public cloud, but also deprovisions them and clean it up once you're done with the lab. So the next person will get a fresh copy of all the resources. And third piece is the hands-on lab backend. This really ties up the whole lab experience together. This is where when customer registered for the lab, the scripts get initiated there. The timer that you see on the top is happening, in the backend systems. The provisioning, deprovisioning, cleanup of all the resources, all those scripts get executed from the backend of it. So hopefully it gives you a better idea how we build this lab. Next, let's talk about the experience. So currently you should be able to have access to VMware vWorld 2021 portal for hands-on lab, and you'll be able to see NSX Cloud Lab there. If you can, just in the top search bar, search for HOL 2227, and you'll be able to get to this page where you will be able to enroll by clicking that big blue button on the top right. Once you enroll into the lab, you'll be able to start the lab itself. And the lab experience is, as I mentioned, it's a multi-cloud lab. So we have resources on premises, we have resources on AWS, and we have resources on Azure. Our management plane runs on premises, and our compute plane run on AWS and Azure, and also on premises because we have one hybrid application. The backend server tie up everything. So your timers, the registration, the deprovisioning, all that happen from the backend. And when you do get the lab registered, you see a main console. And in the main console, we will mostly be using our browser, which is Google Chrome, to conduct most of the exercises of this lab. We will log into our management plane, so vCenter, NSX Manager, CSM, all these are applications or appliances for our management plane. We're going to use browser to get into these applications, UI. And also on the AWS management portal or Azure portal, we'll be using the browser to get to those. And also for our compute, so we have two applications running, and we will be using the browser to get to these applications as well. We do use some PuTTY sessions to check our connectivity between on-premises and public cloud, and that comes usually in later in module 4. But for the most part, we will be using the browser within this main console. Let's quickly talk about these two applications. We have two separate applications deployed. One is healthcare application named OpenMRS. This is a native cloud application running completely on public cloud. It's a two-tier app. So we have web and database layer running in EC2 instances in AWS, and also a separate instance of the same application running in Azure. Then we have our hybrid application, which is e-commerce application AB Cart. And the reason it's hybrid is because it's running both on public cloud and on premises. It's a three-tier app. We have our front or a web tier running in public cloud, one instance in AWS, another instance in Azure, but the other two tiers of this application, app server and database, are running on premises. We use NSX VPN to make the connectivity between the clouds, and later use NSX security policies to secure our application. So we have divided our lab in 4 modules. The first module is Introduction to Public Cloud. It's a 15-minute module. This is, shouldn't take more than 15 minutes to go over this module. Users don't have to really do any exercise in this module. It's mostly the verification. So verifying, all the components on public cloud has been deployed properly. And if you're completely new to public cloud, then it gives you a nice tutorial on how to access, for example, AWS UI or Azure portal. And every individual labs gets a unique AWS and Azure account, which also means everybody gets their unique credentials to get to these accounts. Module 2 is Introduction to NSX Management Components. If you are familiar with NSX management, with NSXT, we have NSX Manager that runs on premises. But in order to utilize NSX Cloud features, we have added a couple more components. alongside with NSX Manager. And in this module, we will go over in depth what are these components and how to access them. Module 3 and Module 4, where is really the meat of the lab is, where you do a lot of exercises in order to make these applications work. So Module 3 is securing native cloud application. From previous slide, if you remember, our native cloud application is healthcare application, OpenMRS, that is running in AWS and Azure. And in Module 3, we create NSX security groups and NSX security policies to enable the traffic to this application, and after that, customer or user will be able to get to the application itself. In Module 4, we secure hybrid cloud application with NSX, and this is again our AB cart application that's running both in public cloud and on-premises. So in order to do that, in Module 4, we first do the VPN connectivity using NSX VPN between the clouds. Once we have the connectivity, then we enable the NSX security to make sure that users have access to, for example, port 80 to get to our applications. So that's the flow of the complete lab itself. But because due to the time restraint, we will only be focusing on Module 3, which is a 60-minute module, and we will go over each step of the Module 3 to go ahead and secure and make the native cloud application work. All right. Next, I will talk a little bit more about the NSX Cloud solution itself. This is how the NSX Cloud Footprint looks like. So in the top, we have a management and control plane, and then we have public cloud gateway and the data plane where our virtual machines are running. So let's go from top to bottom. Our management plane is running on premises, and it consists of NSX Manager and Cloud Service Manager. Both of these are appliances that are already pre-deployed for you in the lab. The NSX Manager and Cloud Service Manager have a one-on-one relationship, and from the Cloud Service Manager, we will be deploying the public cloud gateway in VPC and VNet. We also add different public cloud accounts that we would like to manage from via NSX in NSX Cloud Manager. So this is mostly your day zero preparations. And from NSX Manager itself, we will be doing most of the day two work. So securing our applications or creating the network segments, all that happen from NSX Manager. So NSX Manager is a place where we see the complete inventory of our workloads, workloads that are running on premises or natively in public cloud, or even services that are running in public cloud like S3 storage or Lambda functions, you name it. All that is available in a single pane of glass under NSX Manager. Now, we have connectivity between our management planes on premises and in public cloud, and this can happen directly over internet, over direct connect, express route, or even a site-to-site VPN. In our lab, we are using direct internet access. So when we deploy public cloud gateway through Cloud Service Manager, Cloud Service Manager makes an API call in AWS and Azure, and the connectivity gets established there. It happens over port 80 and 443. from both Cloud Service Manager and NSX Manager to the public cloud gateway. It's a one-way connectivity, so our customers don't have to poke holes within their firewall in order for these two components to work securely. Once we deploy the public cloud gateway, within the data plane, you have two options on how to enforce these networking and security policies that you create in NSXT. The first enforcement mode is cloud enforcement mode. This is the mode where our gateway changes the native security groups and policies of the cloud to mimic the policies that you have created in NSX Manager. And the other enforcement mode is NSX enforcement mode. In that enforcement mode, we deploy NSX tool or agent in individual workloads, and that becomes our enforcement place. So from the public cloud side, we open all the traffic. We don't manage anything from native security groups or security policies in the public cloud, but we make the enforcement right at the source in the workload itself. Now, customer can pick and choose which enforcement mode they would like. The boundary of the enforcement mode is within a VPC or a VNet. So if you have multiple VPC or multiple VNet, you can pick and choose which enforcement mode you would like within an account. So if you have 10 VPCs, you could have 5 picked for cloud enforcement mode and the other 5 picked for NSX enforcement mode. Features wise, there is not much difference between these two enforcement mode. It really comes down to what suits best in your architecture. Great. So next we will go over our NSX Cloud components in little depth. The first one is NSX Cloud Service Manager. We also call it CSM. And CSM, as I mentioned, deploys within management plane in next to your NSX Manager. It get tie up with your NSX Manager. It has one-on-one relationship. And in our lab, we have deployed this whole management plane on premises, but you can deploy the NSX Manager and the Cloud Service Manager, so our management plane, on public cloud also. So you can do that in Azure via a marketplace, or you can do in AWS via AMIs, global AMIs. Cloud Service Manager onboards the VPC or VNet that you would like to secure with NSX Manager. Also, this is a place which configure default quarantine policy for your VPC and VNet. And you deploy your public cloud gateway through Cloud Service Manager. So Cloud Service Manager is also responsible for the whole life cycle of public cloud gateway and NSX tools, NSX agents. Next, we will talk about public cloud gateway itself. So public cloud gateway is our local NSX control plane in public cloud. It gets deployed within VPC or VNet, and the deployment process is completely automated. You just have to provide few information on like which VPC you will like to deploy the public cloud gateway, and you click the button and everything. NSX Cloud take care. Deployment happens over automation. And in this lab, in module 3, we will go through that process. It's a day 0 process, but it's a very easy and fast process. So we'll like you to experience that, and that's why we will go through it in the lab itself. The gateway, enforces the quarantine policy. It also enforces the DFW policies, so your firewall policies, to either, depending on which enforcement mode you have picked, either to your native cloud or directly in the agent itself. You can also enable this NSX Edge gateway for north-south traffic, so public cloud gateway for your north-south traffic. But by default, this all the traffic goes over the public cloud underlay. We deploy this application in an HA pair. They are in active standby mode. There is a heartbeat between both applications, EC2 instances, and if for any reason the primary goes down, the standby becomes active and take over control. As I mentioned, the public cloud gateway is available in public AMIs and VHD in Azure. But the deployment process is automated, so most of the time you don't have to worry about that. With public cloud gateway, you deploy it in one VPC or VNet, but you can manage multiple VPCs and VNets through one public cloud gateway. All right, next let's talk about NSX Tools, aka Agent. This is again an optional tool that you will need to deploy within workload if you choose to pick the NSX enforcement mode. If you do deploy this tool, this becomes your distributed data path. This is where we enforce distributed firewall policies, and all the traffic goes through this NSX tool. So, logical switching, routing happens there, and then we can also do NSX overlay on top of public cloud underlay through this tool. The tool is great for zero trust security architecture approach because you can embed the tool within AMIs, so as your customer deploying the AMIs that you approve of, the tool is already part of it. Or you can also set the option to deploy NSX tool automatically in Azure environment. So as the new virtual machine comes in, the public cloud gateway will deploy the NSX tool for you on those virtual machines. All right, next we will go over the architecture diagram of the application OpenMRS that we used for our module 3, which is the scope of our workshop today. Okay, here I have drawn an architectural diagram for our module 3 application, which is OpenMRS. So we'll start with on-premises. I have a vPod deployed on premises. We call it HOL 2227 vPod. In here I have vCenter deployed and NSX Manager and Cloud Service Manager appliances deployed as virtual machines. All of these appliances are deployed on management subnet, which I created within this vPod. And we also have within management subnet NSX Edge deployed with this IP of 10.114.221.33. And we also get our internet connectivity to this vPod. And on the other side, on the public cloud side, I have two public clouds. So on the vPod, we only care about the management plane for module 3. And our compute is on public cloud. So let's start with AWS. I have resources dedicated in AWS US West 1 region. And there, what we have done is we have deployed two VPCs. We named them Transit VPC and Compute VPC. Within Transit VPC, we have deployed our public cloud gateway. The deployment of public cloud gateway happens from Cloud Service Manager, and this is one of the exercises in the module 3 that you will be performing. You will be deploying the public cloud gateway from CSM and see how easy and how fully automated the process is. During the deployment process, our automation also creates multiple subnets within this transit VPC. And one of the subnets called NSX Management Subnet. Here's the IP range for it, and this is where the management or public cloud gateway get deployed. What we have also done with the automation is when we deploy this compute or transit and compute VPCs, we have also did a VPC peering between them. This is already done within the lab. The other process which has already been done is the deployment of the virtual machine itself. These are the compute virtual machine, our application OpenMRS. So it's a two-tier app. We have deployed the OpenMRS Web 01 AWS VM or EC2 instance. So these are EC2. And both of them, so one is web and one is database. They are both deployed on NSX Compute subnet. And we have the users coming in, going directly to the OpenMRS web interface. And all the networking you see is done here is completely AWS overlay. So we are not using any NSX networking for this application. The only feature we're using from NSX side is the security piece of it. So we create a distributed firewall and creates the rules in NSX Manager to do things like open port 80 so users can go to, so this is on port 80, so user can connect to the website directly. So these rules we create in NSX Manager. NSX Manager pushes the rule to NSX Public Cloud Gateway, and Public Cloud Gateway enforce those rules by creating different security groups. So AWS security groups to open port 80, for example. So this will be the exercise that we will be doing in module 3. Now we have exact same replica of this architecture created in Azure. So let's go over it quickly. Via internet, we use Azure Overlay Networking. We don't use NSX Networking for module 3. And in here, we deploy NSX Public Cloud Gateway. Again, the deployment process happens from Cloud Service Manager. Everything is automated. And then later on, the life cycle of this public cloud gateway, like updating it and making sure everything is running, all that happens from Cloud Service Manager also, right? So when the automation takes care of creating all the subnets, we have already created Transit VNet and Compute VNet in in Azure West US region. And within the Compute VNet, we have deployed two virtual machines, OpenMRS Web 01 and the database service for that application. And again, user goes directly to the public IP that has been provided and access the OpenMRS web UI. But one of the cool things about NSX is when we do create this open port 80 rule, firewall rule in our NSX manager, we just create it once, right, for our OpenMRS application. And regardless if the application running in multiple places and on public cloud, NSX realize those security policies in both AWS and Azure. So this is what we have for module 3. And next we will jump into the lab itself, the exercises itself, and we will start from module 3 and we'll finish that module in this session today.
Hello everyone, my name is Mohammed Haddad. I am a lead VCN solution engineer. Today I have with me Puneet, who's going to be leading this workshop in the beginning, but I'm going to show you the lab for module number 3. So I'm going to share my screen right now. And before I jump into the lab, I'd like just to show you the topology for the hybrid app, because what we're going to do in module number 3 is we have an application that's living in the cloud natively. That application has a web MDB living in AWS and all have the same instances running in Azure. So we have 2 clouds here to manage. Now, the beauty of NSX Cloud is you can have multiple clouds, multiple accounts, all of them managed from a single pane of glass, which is NSX Manager. So NSX Manager and CSM are going to be the ones that are going to enable us to do the policy. And when we do the policy, we're matching criteria for 2 clouds. And when we do this, then we have only 1 policy for the cloud. So even if you move the VMs or change IP address, we don't really have to worry about that as long as they keep the same tags and they match the criteria. Now, to be able to do this, what we do is you deploy a VPN, it's a PCG, it's a public cloud gateway. It's the same NSX Edge that you deploy on-prem, but we deploy it in the cloud. That's why we call it PCG. And then we deploy one in transit VNet in AWS, another one in transit VNet in Azure. And then we link the compute VNet to the PCG. Why we do this linking is because we don't want to really deploy a PCG per VNet. We can do this, by the way, but it takes resources as well. So it's going to be a cost in the customer. So what we try to do is we deploy a PCG in one of the VNets, and then we link other VNets to control the policy in these VNets. So as you can see here in the Azure Transit, we deploy the PCG, but in the compute VNet or VPC, we did not deploy any PCG, and we're not going to use any tools or NSX tools or any agents on the native application. So with this way, we're going to do an API call, and that API call will actually push the policy to the native applications. That's the topology. We don't really need a VPN. We don't need anything for this to work. All we need is HTTPS outbound from NSX Manager and CSM to the PCG, because PCG will be the one pushing the policies as well to the native application living in the cloud. Now, let me go to the lab. Once you subscribe to the lab or enroll, when you open the browser, the first thing you're going to get is this login page. So what you do is you log in with your own email that you registered for this lab. And the password is very simple. It's actually VMWare #1 and then exclamation mark. That's the standard password that we use for these type of labs. Now, once you log in, you see that you have the information for you to log into the AWS, information to log into Azure. You see the public vApp IP address, which is actually to build the VPN for module number 4. So it's like your on-prem public IP address for the firewall to do VPN site to site. You see the URL for the hybrid app, the native app, and also you see the login for Azure. And for Azure deployment of the gateway, we have something called a public key that we need to use for the deployment. Now, the first thing we're going to do for this lab is we go to module number 3 on the right side. Okay, the first thing we have to do is actually to deploy the public cloud gateway. Now, before we go further, 2 things I would like to know. It's better to make sure that you have the lab status is ready. So you make sure that the lab, because you have some scripts running in the background, if it shows you timed out or there's some error, don't continue the lab, just end the lab and launch a new instance. And another tip is to go to Zoom 90, because that will show you full screen of the lab, so you don't have to scroll up and down when you're going through the lab. So that's the first thing they will ask you here in this. We'll ask you for this in this lab is to go and log into the CSM. So that's the first thing. So now I'm going to go and log into the CSM. I'm going to open a new tab. I'm going to log into CSM. I'm going to go proceed. The username is admin. The password is loaded here. As you can see, we can just select the password and then drag and drop the password here, so we don't have to type it multiple times, or we don't have to do any mistakes. And once I log in, I go to light mode because I like the bright GUI. Now, if you go to the clouds, what you're going to see is AWS. We have already added the AWS account for you. It's a live account. In Azure as well, we have added an account. These accounts are live. They are dedicated for your lab. And every time you end the lab, we free these accounts to other labs. So the first thing we do is we need to deploy the PCG. So the first thing we go AWS, we're going to go VPCs. And then we're going to see two VPCs mainly, the transit VPC and the compute VPC. These are where we want to deploy the PCG on the transit, and then we link the compute to the transit VPC. I'm going to quickly deploy the PCGs. Usually take around 10 to 17, 18 minutes, depending on the cloud. And then we can actually start doing all the policies. So the PIM file is called management. We're going to manage with NSX Tools. This is only if you're going to do module 4, to be honest with you. We're going to use manage with NSX Tools. But if you're not going to do module 4, you don't really need manage with NSX Tools. But I'm going to move with the lab sequence. For the connectivity to the gateway, we're going to use auto-detect. So we actually can do connection PCG to the private IP address or the public IP address. But for this lab, we're going to keep it auto-connect, and we don't have any proxy server. Now, if you go to the next tab, we can actually deploy the PCG in HA mode. But for this lab, we're going to remove the HA mode. We're going to deploy it only single instance. So if you go to availability zone, you can see A and C. Usually it's B or A. We're going to select A. And then we're going to see all the segments of where we need to connect the PCG. So every PCG have 3 links. One is uplink to connect as a VPN or get IP address. And the other one is actually for management. And the downlink is actually to connect to the VNet itself. So the uplink is called uplink subnet. The downlink is the download segment. And the management is the management segment. Now, for the public IP address, we're going to use a public IP address for managing the PCG. So we're going to select allocate a new IP address. And also for VPN, in the module number 4, we need a public IP address for the PCG to establish a VPN connection. That's why we select also allocate a new IP address. If you were not going to do a VPN and you're going to use your own Palo Alto, Fortinet, and so on, you don't really need to allocate any public IP address on the uplink. You just allocate it on the management. And even on the management, if you have a private VPN already done, you don't need a public IP address on the management. But for this lab, because we have it in the public cloud, we are allocating the management and the uplink public IP address. We're going to use NSX to do the VPN in module number 4, not number 3. So I'm going to click deploy for the AWS. As you can see, started deployment. You can close this tab and go to the Azure site and start the deployment again for the PCG. So you don't have to really wait for the deployment to be fine to finish and then go to Azure. You can directly go to Azure. I'm going to say deploy public cloud gateway. As I told you before, there's this SSH key that we need to copy from the hands-on app manual. So I'm going to select the SSH key. Make sure that you select all the parts of the SSH. You cannot Control-C, Control-V, just right-click copy. We're going to go here and paste it. We're going to say manage with NSX Tools. We're going to say auto-install NSX Tools because in Azure, we can auto-install NSX Tools. But for this lab, for this module C, you don't really need these two. But if you're going to continue for module 4, you need to have these enabled beforehand. Again, we're going to use a marketplace image. So now we have our Azure image for PCG in the Azure marketplace. So you don't have to copy it from any account. And then we do the same thing. We're not going to select HA mode. And as I told you before, the uplink is the uplink segment. The PCG will have 3 links. Downlink is for the downlink segment. And the management is for the management. And because we need a public IP address, we're going to allocate IP address for the public IP address for managing the PCG and another public IP address to do the VPN. And then we click deploy. Now, as you can see here, it's also going to start the deployment. It's going to take another 15, 20 minutes. But in order to move forward, I'm going to close these. You can see, I can see this status showing that it's being deployed. If I go to AWS, you see the same thing, that it's being deployed. We'll leave this page for now. We're going to continue the lab and come back and see how we link the compute VNet to the transit VNet. So the first thing we're going to do is we're going to do an inventory review. So if you go here to the table of contents, after you deploy the gateways, you need to actually link them, but we're going to skip this till we have them up and running. Now let's verify the VMs in the Azure and AWS. So we're going to look into Azure and AWS and see the VMs and their tag. So let's go to Azure, the AWS first. I'm going to open this in a new tab. It's going to ask you for username, password. They're actually noted over here. Just right-click copy and right-click paste. This is the password, copy. That's the username. And this is the password. Let me confirm. Okay, let's log in. Okay, so you're following up so what you can do is you can go to services, EC2. And when you go to EC2 instances, we see all the VMs that we have running in the cloud. You go instances. What you'll see here, we see all these VMs running in the cloud. We can move this down for better visibility. So what happens here, if you look here, we have OpenMRS Web. It has an IP address and it's sitting in the VNet, which is actually the VNet for the compute. Okay, and has also a public IP address. If we go to the OpenMRS DB, it's the same in the same VNet as well. It has an IP address. And you can see here the public cloud gateway being deployed. So right now it's running, but it's not yet fully deployed. So right now I'm going to select the web. When you select the web VM, you can see all the properties of this VM. You can see the tags. As you can see, this VM is being tagged right now with the name, and app here is web, and the app name is OpenMRS. So what you're going to see in the NSX, we're going to try to match these tags. And if they match, then what's going to happen is that OpenMRS web will be automatically added to the web group. So in the future, if you're adding more web servers, all you have to do is make sure that they are tagged with the web and OpenMRS, and automatically they will be added to the policy. That's one of the main benefits of NSX Cloud. It's like the same policy being dynamic, and that same policy is matching not only the web servers in the AWS, but it's matching also the web servers inside Azure. So it's going to be a single pane of glass, a single place, and a single policy to match the VMs in the cloud, in AWS and Azure. If you go to the DB side as well, it also have a tag. And as you can see, it's actually called app tier DB, and the app name is OpenMRS. And these are the tags we're going to use to actually match them in NSX. From a security perspective, if you look at the security policy, we have already a security saying that inbound and outbound is actually, inbound is nothing is allowed, as you can see in the inbound rules. And in the outbound rules, you can see there's only allowed any. So in this case, only to the NSX within the VNet itself. So in this case, if you try to access that application, it should time out because we don't have any policy, any rule to allow communication from outside. Okay, so let me try the application from Amazon. So I'm going to click on the OpenMRS web. What you're going to see is the page will open, but it's going to be timing out because there's no policy that allows the communication from outside to the web server. There's no policy that allows the web to talk to the DB at all. So that's why you see that the application will time out. Okay. Until this timeout, I'm going to log into Azure site. You're going to see the same, probably similar output where the VMs are tagged with certain tags. That's the username. We're going to copy the username from here. Click paste. We're going to go to the password, copy the password. Okay. As you can see, AWS already timed out. So it's telling you that we could not connect to the web. So we have something called mini proxy, which is our proxy server, trying to connect to that web server and feeding an error. It's timing out. Now let's go to Azure side. Go to the virtual. If you get any confirmation email address or marketing or anything, you just click close. You go to the virtual machines. You'll see the same virtual machines like OpenMRS DB and web, another instance living in Azure natively. You can click on any of them. Okay. You can go to network tags first. Let's confirm the tags. You can see it have an app name called OpenMRS and have also the web as an app tier. So the same tags are being available in Azure and in AWS for the web. And it's the same thing as well for the application living, a DB application living in Azure. So it's tagged with app tier DB and the app name is OpenMRS. Now, if I go to the security of that virtual machine, so if I click on this one, networking, and see the security. Okay. You'll see that it has a VNIC, and that VNIC is having these rules. And you can see that the rules are allowing only communication within the VNet itself and to Azure Load Balancer to talk to them, but everything else is denied. So there's no rule inbound to allow communication from outside. Outbound is similar. We have no rules in outbound. It just deny any at the beginning from the internet. So there's no communication allowed from outside. Okay, it's allowing only from within the VNet. If you go to the web server, we see similar rules that it doesn't have any rule allowing incoming web to the web server. And we don't see any outbound rules to be allowed to communicate with the internet. So as you can see here, we don't have a rule to allow communication. Now we can go and click on the link. And if we click on the link for the OpenMRS, you'll see it's timing out as well. Okay, this will time out. Let's us check the CSM and see what's the status for the VPCs. Still, it's being deployed. We're going to continue our lab and look at NSX Manager. If you look into the NSX Manager, look at admin. The password is VMware 1 bank, and then VMware 1 exclamation mark twice. Okay. If you go to networking, what you see, because these PCG will be deployed, you will see a new, first of all, you see new edges being deployed. So if you go to system, fabric, nodes, you see new edges being deployed in the public cloud. The same NSXT edge, but you'll see them being deployed in the public cloud. That's the first thing. You see public cloud gateway for AWS and for AWS and for Azure. These are two of the public gateways that are being deployed. VPC, it means it's AWS, and if it doesn't have VPC, then it's for the Azure side. As you can see, the public cloud gateway for AWS is now up, and for Azure, it's not yet up, it's being deployed. If I go to networking, you see new T0s created. Once the PCG is up and running, you see now we have the PCG for AWS up and running, so you see a new T0. Once we can link the VPC for the compute to the transit, you see a new T1 created. These are not really mentioned in the lab, but I'm just giving you here as well. You can see the T1 being created for the VPC of the transit. We see another T1 created when we connect the compute as well. So the point here is it's exactly the same networking and look and feel when you go to Azure or AWS. It's the NSX Manager being deploying the public cloud gateway, and then we create T0 and T1s based on the compute VPCs and VNets. Now in the inventory, what we have done to make sure that you get this done quickly, we have actually created the groups that we need for OpenMRS. So if you look to go to the OpenMRS right now, you can filter here, open. You see there are 3 groups. In the first group, we actually put all the members, all the VMs of the OpenMRS. So if I go edit criteria, you see that the criteria is actually based on 2 things. It's based on the tags, yes, but it's matching all the VMs that have OpenMRS in their app name. Okay, so that's what we're matching. So if it's even in Azure, or AWS, we're actually matching the name of that VM. So you can see this discovered Azure app-name and discovered AWS app-name. If they match, they will be added to the policy, to the group. So in this group, we should see 4 VMs, all the VMs for web and app in both AWS and Azure. If you go into the DB, it's a bit different. We're matching only the DB server. So we actually go edit, check the criteria. You see that we're matching that the VM have DB tag and OpenMRS tag. So if it's a DB and app in AWS, I want to put it in this cloud. And if it's also a DB and app in Azure, I want to put it in this group. So now in this criteria, we're matching only the DB servers. Let me click cancel. And same for the web. If you click on the edit and check the criteria, you'll see that also we're matching the web and OpenMRS. We're matching if it's web and OpenMRS, then we're gonna put it in this group, and we're matching web and OpenMRS, then we'll put it in this group. We're matching multiple clouds with the same tag. So this group should only contain the web servers. It should not contain the DB servers. Okay. Now, if you click on the view members, you should see no members because we did not link the compute VNet where the native VMs live to the transit. So once we link them, you see the membership automatically populated. So all the groups are empty right now. So that's why you see them empty, because we don't have any link between the compute and the transit VPC. So right now, let's go to CSM. This should be, everything should be up and running. Let me go first all to AWS. You can see the gateway is deployed already and it's up and running. What we need to do is we need to link the compute VPC to the transit VPC. Let me go here. I'm going to go actions. I'm going to get link to transit VPC. So I'm going to close transit VPC. You see this transit VPC, which where they have the gateway deployed. Because it's a native app, we're not going to install an agent. I'm not going to select NSX Tools. Okay. So click next. This will take around a minute to complete. Once it's complete, you'll see that the inventory inside the compute VPC will be now populated to NSX. NSX will try to see if they match any criteria for the policies or the grouping, and then you see them in the group. Let's go to AWS, Azure, sorry, and let's see the status. Okay, now the gateway is deployed. We're going to go to the compute VNet. We're going to deploy link to transit VPC, sorry, transit VNet. We're going to select the transit VNet where we deployed the gateway. We're not going to select NSX Tools. Next. And now it's being linking the compute to the transit VNet. Again, once this is done, all the inventory, all the VMs, all their tags will be populated in NSX, will be learned by NSX, and then we can do grouping based on these criteria. As you've seen, the criteria are there. The grouping is done for you. You can create your own criteria and grouping. But the point here is multiple clouds, multiple VMs, we're matching them in a criteria in a single policy, single group, and that group is dynamic. That's the key thing. It's dynamic. If they decommission any web server, automatically you will be removed from the web server group. You don't have to clean up. You don't have to go and manage your policies every time the system admin bring up or break down certain VMs in the cloud. Okay, we'll keep this running, so it's done. So now we're done with NSX, with the CSM. Actually, we have the accounts added, we have the gateways deployed, we have the instances now being populated. We can see the gateway, the OpenMRS DB, the OpenMRS web, the native AD card application, but we're really focusing on DB and web for management. Same for AWS, we see all the instances as well. And you can see they have exclamation mark because they are not yet managed by any policy. So you see exclamation mark, it's saying no NSX policy is configured for these VMs. So now let's try and see the NSX here. Let's go to view members. You can see automatically now we're populating the membership for these criteria. Because this application have 2 VM, this criteria have all the OpenMRS VMs to be matched. If you go back to the criteria, we see that. So what you see here in the criteria, it's matching based on the being tagged as OpenMRS, and all the VMs are being tagged as OpenMRS. Now we see the AWS side, but soon enough you'll see as well the Azure side. So let me refresh. Okay, Let me filter again on OpenMRS. Let's go to members. Now we see the Azure and AWS. So as you can see, it takes like 30 seconds to populate these in the inventory, and now we have them matched. If you go to the DB, we should see only the DB server, AWS and Azure. Click view members, you see the AWS and Azure are running here. And if you click on the web, we see also the web servers only matching here. So now we can actually create a policy. If you go to security, distributed firewall, we don't have a policy for the OpenMRS. We have only a policy for the AD card. So if the default rule is saying deny everything else. So it means if there's no policy matching before, we're gonna drop all the traffic. And that's why nothing will work right now. So we have to create a policy. We're gonna create a new policy. We're gonna call it OpenMRS policy. Okay. And then we click on the three dots. We click add rule. The first policy we need is to allow web traffic coming from the internet to the web server, and it has to be only HTTP. So I'm going to call it internet to web servers. So the source will be any, the destination. I want to select only the web servers. So I can say web. OpenMRS web. Okay. And then I'm going to select the server, which is HTTP, which means I'm allowing HTTP traffic coming from outside. Okay. Now we have the first rules allowing internet to come from outside to the OpenMRS web server on HTTP. If we try to access it with this rule only, we'll not be able to reach the DB. So now we need a rule to allow the web server to talk to the DB on MySQL. So I'm going to add another rule. I'm going to call it web to DB. Okay. One thing I'd like to note here, as we did not select to where to apply this rule, it's better to select to OpenMRS. So that's why we have a group called OpenMRS. We don't want this policy to be deployed everywhere. We need to deploy it only where the VMs are living. So we're going to select OpenMRS group. Okay. Now we're going to go back to this rule, say web to DB. We're going to select the web servers. So I can drag and drop, by the way, because this is really easy. So in the destination, I'm going to select an OpenMRS as a source and OpenMRS as a DB as a destination. So here I'm going to say open. I'm going to select the DB as a group, not the web. Okay. And I'm also going to select the service as MySQL because that's the protocol we need for this communication. Apply. Now we're going to also select the same group to be applied only to, and all we have to do now is click publish. Okay. Before I click publish, let me show you again the security inside here. You can see OpenMRS web security. There's nothing. Okay, there's nothing for the outbound. There's nothing for the inbound. Same for the Azure side. If you go to the Azure side, you can see there's no, as I showed you before, that it's still the same policy. Okay, but what's going to happen when I click publish, an API call will be done to the Azure API servers. And then that policy will be populated here automatically. So now let's go and click publish on NSX. Okay, now what's going to happen is now we're going to see that this policy being actually pushed to the PCGs inside the cloud. As you can see, this is the public cloud gateway. That's for Azure, because AWS plus VPC, and that's for Azure. Because they are matching both and they have the VM that match the criteria, we're pushing it to these two edges or PCGs in the cloud. Now the policy is pushed. Now if you go to the instance here, let me just refresh. I'm going to click on the web, security. Let me bring this up a little bit. You see soon a new rule being allowed here. So you can see right now there's only TCP 2220 SSH, but soon enough you'll see as well other rules being populated. Sorry, I clicked on the wrong VM. It should be web. OpenMRS. Let's go to security. And as you can see, on the web server, now we have port 80 being allowed from anywhere. That's inbound. Outbound, we're allowing from web server to talk to only the DB server on MySQL 3306, and we used a security group for the grouping here. If you go to the DB, you see we're allowing communication as well we should be allowing communication for MySQL. Okay, so you can see inbound rule will allowing MySQL to be allowed from this segment, which is the OpenMRS web server segment, and we're using security group. If you go to Azure, let me go to the Azure side, just refresh here. You'll see similar rules that being allowed, allowing port 3306 and allowing port 80 from outside. And you can see we're putting the rule ID here. So that's matching the rule IDs inside NSX. And then we're using a network security group to group this in the Azure side. If you go to the DB, we'll see similar policies to allow communication on this DB on 3306. So in short, what you're seeing here right now, instead of you creating these rules on your own or doing API calls and taking so much time, and if you have multiple accounts and multiple clouds, it becomes more and more operationally prohibitive. What we're trying to do with NSX is having everything running from a single pane of glass. So now if you go to the application, to the URLs that we're not opening, let me close it, and then we open it from the manual. If you go to AD card, let's click on the OpenMRS hub. You see it's going to open. And let's go to the AWS side and click on it, and it should be open. So as you can see right now here, we already logged in. We can log into the OpenMRS. Same for the Azure AWS side, it's opening. Now, just a small note, we have a problem with the OpenMRS running in Azure in AWS. So even if it doesn't open, but it gives you this information, this page, this means that you reach the web server. So there shouldn't be a problem, but it should be opening like this in the Azure side. So the point here is now we can actually log into the OpenMRS application. As per the manual, there is username, password, you can check it and you can log in. But the point here is we were able to create a policy from a single pane of glass for the two accounts, for the two Azure clouds. And you can see how simple it is to manage it. It's not like you're gonna learn a new technology or new terminologies, because in AWS and Azure, they have different terminologies. For example, the VRF or the segment is called VPC in Azure, VNet VPC in AWS and VNet in Azure. They call in AWS there's something called security groups. In Azure there's something called network security groups. So it's a bit of really a lot of lots of things to learn when you go to the cloud. We're offloading this for you and we're giving it to you in the NSX Cloud, or the NSX, which is actually that can manage the on-prem and the off-prem policies in the cloud. So that's the purpose of module 3, without opening any VPN, without anything. But if you want to take it a step further, you can use VPN from NSX. You can do VGP with NSX to advertise all the VNets connected, and that would help you as well in type of management and having connectivity to the public cloud. So I hope you enjoyed this lab. Sorry, I did not follow the manual because of the deployment of PCG takes time. So I wanted to skip over and then come back to the PCG. But I think the point here is very clear on how we manage the policies in multiple clouds from a single pane of glass. Thank you very much for listening. I hope you enjoyed this lab. You can do this lab at any time. The modules are not dependent on each other. You can start module 3 alone or module 4 alone. In module 4, we have also deployment of PCG. But if you have deployed it in module 3, you don't have to redeploy it in module number 4. Thank you very much for listening, and I hope you enjoyed it. Thank you.